Now we're going to look at a super awesome pattern. Let's say I want to expand or multiply out the binomial a plus b to the n below for exponents 0 through 4. Okay? And I'm going to eventually do 5 and 6, but let's say I want to do 0 through 4. So let's do that first. So if we have a plus b to the 0, that's 1. Very easy. A plus b to the first. Oh, you guys are geniuses. That's a plus b. A plus b squared. Hopefully you have this one memorized, but in case you don't, I multiplied it out up here for you. You get a squared plus 2ab plus b squared. A squared plus 2ab plus b squared. Now, most of you probably do not have memorized the pattern for a plus b cubed, but a plus b cubed, let's just write it over here. A plus b cubed is just going to be a plus b squared times another a plus b. So I'm going to write out a plus b squared. A squared plus 2ab plus b squared. And I'm going to multiply that times a plus b. Now my favorite way to multiply is to start with a and multiply a times everything in that set of parentheses. So a times a squared, a times 2ab, a times b squared. So a times a squared would be a cubed. A times 2ab would be 2a squared b. A times b squared would be a b squared. Notice I'm going to always put the a first and the b second just to be consistent here. Then I'm going to take b and multiply it times everything in the second parentheses. And I'm going to kind of back that off. So kind of everything times the second parentheses. There we go. So b times a squared would be a squared b. A squared b. Notice I'm going to write it underneath the other a squared b I have because I'm going to add those together in just a minute. B times 2ab is 2ab squared. So 2ab squared. I've got another ab squared to add that to. B times b squared, b to the third. So when I add those together, I've got 6 terms when I multiply out. I'm going to get a cubed plus 3a squared b plus 3ab squared plus b cubed. And I'm going to add this to the next line in my little chart here. A cubed plus 3a squared b plus 3ab squared plus b cubed. Okay, now a to the fourth. All right, so a to the fourth would be a to the third times a plus b. So there's a little space down here where you can multiply this out. And you might want to try this on your own first. I'm trying to find my little thing to scoot this over here. I have it all multiplied out, but it would be good practice if you're feeling a little shaky about your multiplication. You might want to multiply this out and just make sure you're good with this. But here's what I did. Let me erase this stray mark here. So I have a plus b cubed times a plus b. I wrote out the a plus b cubed. I multiplied everything in all these 4 terms times a. Then I all these 4 terms times b. I lined up the like terms and I added them together. So take a look at that. Pause if you need to. Make sure that that makes sense to you. Or better yet, even pause and multiply it out yourself so that you know what you're doing with that. And then compare it to mine. Now, I'm going to take the result of that and put it in my chart. I have a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth. Now, if you took the time to multiply that out yourself, you'll recognize that that's a kind of a tedious thing to do, and it'd be really nice if I didn't have to keep doing that for a to the fifth, a plus b to the fifth, and a plus b to the sixth. Never fear. We're at the point where we're going to start looking for some patterns now. So I'm going to show you one pattern that I think that you might notice, although you might have already noticed a pattern already. So what I want you to see here is looking at the coefficients. Look at the coefficients. Well, we start with 1 here, and then we have 1a and 1b. So I'm just going to put a little number 1 above those, 1a and 1b. Then if we look at the next one, we have 1a squared plus 2ab plus b squared. Then we have 1a cubed plus 3a cubed, a squared b, plus 3ab squared plus 1b cubed. 1, so we have 1 here. 1, 1, 1, 2, 1, 1, 3, 3, 1. And look what we have now. 1, 4, 6, 4, 1. This should remind you of what we just did on the previous page with combinations. They are exactly the same numbers that we had when we did 4 letters select 0, 4 letters select 1, 4 letters select 2, 4 letters select 3, 4 letters select 4. So these combinations, the reason the combinations are also called binomial coefficients is because this is a binomial, and when we multiply it out, these are its coefficients. So that is the way we figure out binomial coefficients. So let's just looking at the pattern here. We also see a lot of patterns with the exponents. What you might notice is whatever power this is raised to, that's my that's my exponent on my first a. So I have a squared here, a squared, a cubed here, a cubed, a fourth here, a to the fourth. Then notice what happens is the exponents on the a count down. A to the fourth, a to the third, a to the second, a to the first, then a disappears. Or you could think of it as a to the 0. No b on the first term, then I have b to the first, b to the second, b to the third, b to the fourth. Notice that the exponents always add up to whatever that exponent is. So 4, 3 plus 1, 2 plus 2, 1 plus 3, 4. Always something to the fourth power. So when we see a plus b to the fifth, we can tell that our first term is clearly going to be, oops, I'm going to put this in black to keep it standard here, a to the fifth. Now if you look at the coefficients, this is 2, 3, 4. The second coefficient always matches the exponent on the binomial. So this should be 5. And going with our pattern, this should be 5a to the fourth b. Now I'm going to leave it blank for the coefficient because I don't know what my coefficient is here yet, but we're going to figure that out in a minute. But then the next one should be a to the third b squared plus, leave a room for the coefficient, a squared b to the third, leave room for the coefficient. You know what, I'm going to scoot this over maybe just a hair. I don't think I left much room because my pen's kind of fat. There we go. Plus a b to the fourth plus at the end b to the fifth, which would just have a coefficient of 1. Oh, I should also recognize that this would be 5ab to the fourth because if I have a 4 here, that's the second term. The second to the last also has a coefficient of 4. So I should have a 5 here and a 5 here. But these two middle ones, I'm not sure about. So I'm going to show you a really nifty pattern now to show you how to figure this one out. The pattern is called Pascal's triangle, named after a mathematician named Blaise Pascal. Also is a philosopher too. You might have heard of him in philosophy or theology as well. So we start out at the tip with 1, our very first coefficient at the very top of our list above. Then we have 1, 1. Then we have 1, 2, 1. Then 1, 3, 3, 1. You can see how it's forming a triangle. Then we have 1, 4, 6, 4, 1. Now we're ready to write the row that we want to write. You can see it starts out with a 1, 5, and it ends with a 5, 1. But what are those two numbers in the middle? What I want you to notice that every number is the sum of the numbers that are diagonally above it. Like 3 plus 3 gives me 6. 1 plus 3 gives me 4. 1 plus 4 gives me 5. So 4 plus 6 is 10. So this is a 10, and this is also a 10. If I wanted to add another row, the next row would be 1, 6, 5 plus 10, 15, 10 plus 10, 20, 10 plus 5, 15, 6, 1. And we could keep going with this. So the Pascal's triangle also gives us the binomial coefficients. It also gives us the pattern of combinations, whichever you call it. So let's go up and apply that. That means these two numbers here that we're missing for our coefficients are going to be 10 and 10. This also is going to allow us to write a plus b to the sixth, because I can start out now with a to the sixth plus 6, a to the fifth b plus Okay, our next one is 15. Our next coefficient is 15. And count down to a to the fourth, and then count up to b squared now. Plus 20, count down for a and up for b. A to the third, b to the third, plus 15a squared, b to the fourth, plus 6ab to the fifth, plus b to the sixth. Okay, so that is the pattern of coefficients and variables you get when you expand the binomial a plus b to a power. Next video, then we're going to look at something called the binomial theorem.